Okay, we're in the next section. This is after parabolas and circles. We're doing ellipses and hyperbolas. So we covered this in lecture. We covered the ellipse, the features we want you to get from the ellipse. We covered the hyperbola and the features we want you to get from the hyperbola. All right, so what the point now is, we're at the point where we're going to do examples to drive those points across. All right, so we're going to start the examples, and I'm going to move to the whiteboard now. Give me 1 second, I get a cable here. We do a new share, and I'm going to give you the whiteboard. Give me a second to plug in. Okay, you should be seeing the whiteboard. We're doing the examples now, and the example we're going to start with example number 1. So let's just take a look at example number 1. And the first thing I'd like to do is just put in standard form. This could take some time, and the arithmetic may prove difficult for some students. We really do write the problem so the numbers do work out nicely, though. So my first thing to do is just to write it in standard form. So I'm going to write that down for you, 49x squared, and then I got minus 98x. And then what do I have? I have 36y squared. And then what do I have? Minus 360y. And then I'm going to add 815 to both sides. Right, I'm going to factor 49 out, and you get x squared minus 2x plus, I'm going to factor 36 out. That'll give me y squared minus 10y equals 815. Now it's time to complete the square. This is where a lot of students get confused. We're not trying to confuse you, but half of this number, which is going to be 1, and you're going to square it, and you're going to add, whoops, I'm sorry about that. You're going to add not 1 to both sides, but 49. Now, why is that? It's 49 times 1. All right, let's keep going. I'm going to take half of the 10 now, which is 5, square it, which is 25. Now, I'm not adding 25. I'm actually adding 36 times 25 to both sides. So that's going to be 900. Again, if you need time to do arithmetic or you're using a calculator to do that, that's fine. Let's write this down now. This is 49 times a perfect square, which is x minus 1 squared, plus 36 times a perfect square, y minus 5 squared, equals, you got to add those numbers together. So let's see, 900, 800, 1700, and then 15 and 49 is going to be, let's see, 54, 64, right? All right. What are you going to do now? You want to get that to be 1 by dividing both sides by 1764. I'll write that down for you. Again, we're attempting to get in standard form. Okay, what do you get? You get 1. Here, well, let's say I put out 49, and I'm going to write this on the side for you. Let me just, mention to you that 49 times 36 is 1764. Now, someone goes, I don't believe that. I don't believe that would work out so nicely. And I want to remind you, we don't write things unless they're working out as nicely as we possibly can. So you may want to take a calculator now and just do 17 times, I'm sorry, I didn't say 17, 49 times 36 on your calculator. And we'll just give you 1764. So it worked out pretty nicely. We expected it. Now I'll write this down. And 49 go to 1764, then 36 times, plus y minus 5. Whoops, I dropped my pencil. Give me 1 second. Again, the arithmetic for some students proves to be quite difficult. Squared, and 36 goes in 1764 49 times. This is standard form. I want to point out that's written down for you. And the reason for that, we want you to look at the answer and make sure you can agree with that. Now, granted, instead of 36, I wrote 6 squared down. Instead of 49, I put 7 squared down. You don't have to do that, though. All right. So let's talk about the next thing, and that's going to be, the center, the vertices and the foci. All right. Let's not worry so much about eccentricity. All right. So let's take a look. And I'm going to start, maybe putting down a center now. So center, whoops, the center, well, I did it again. The center, pretty easy to pull off from standard form, is going to be 1, 5. All right. Now let's talk about the C. The C squared is going to be the difference between those two numbers on bottom. So that'll be 49 minus 36. And what's that going to give you? That's going to give you 13. So, the C is going to be root 13. Now, certainly when I say that, we're going in and out, so plus or minus 13. So I'm going to say that we give you pictures too to help you with this, right? Just to help you. And I'm going to just go over here. And before I do anything else, I got this C business, but I also want to get other things in the problem that I'm going to talk about now. Those other things are going to be those, characteristic points, the 4 points for circle. They're equal distance. These are not going to be equal distance points though. So what I'm going to do, I'm going to get 4 points. I got the C now. We'll talk about that later. I got the center, 1, 5. Let me put that down for you. 1, 5 is right here. That's the center, 1, 5. Look at my picture. Let's put down the other points I'm going to put down. I'm going to put down x equals 1. And this is nice. And I'll tell you why it's nice. It's easy to do. Someone said, why'd you pick 1? Not because 1 is easy. It's because 1 minus 1 is none, and the first term would disappear. And then what would you be left off with? I want to point out what you were left off with over here. You left off only with this term has to equal 1. Well, that means that this top number has to be 49. Well, y could be minus 2. I'll write that down for you. Or the other value y could be would be, let's see, you'd have to get what? And we'll check this out in a second. It's got to be 7 squared to give you 49, right? So it'd have to be 12. All right, let me go to my graph, and I'll see if those points are there. So 1 minus 2, seeing that right there, and 112. I'm seeing that there. All right, super simple. Let's keep going. Let's go for other points. I'm going to pick now y to be 5. And it's easy. And again, I want to communicate why it's easy. This term disappears. I'm left with this. Now, what am I left off with? Something being squared over 36 is equal to 1. So this top number has to be 6 squared. Now, what would do that for me? I'll write this down for you. Y is 5. What number would make the top, 6 squared or minus 6 squared? Well, I'd say minus 5. We'll check this on my graph later. And the other point would be 7. All right, let's go by picture and make sure I'm seeing that in the picture. And I'm seeing that right here. That's minus 5, 5. And the other point I'm seeing, I'm looking at the picture, it's 7, 5. All right. Now, granted, someone says, well, I could draw this down now. And I want to point out what you've got so far. You've got in the center. You've gotten these points over here. All right. And now what I want to do is I want to put down the foci. All right. The foci are going to be C units in from the center. The problem a lot of students have is they don't know which direction we're going, up or down or left or right. We're going along the major axes. And what's that going to be? That's along the vertical now. The vertical. That number 49 is bigger than 36. So I am now ready to write the foci down. This is one foci here. I'm going to put it in blue for you. And what do I know about that? One thing I do know about it, I do know the x is 1 there. I know that much. The other thing I know about it is we went up root 13 units from that center. So what is the center? It's 1, 5. So if you went up root 13, it would be 5 plus root 13. That's 13, by the way. Let me get my eraser because I think it's too small for some students to see that. Let's do this one here. And what's it going to be? Well, the x is still 1, and the center was 5, but we're going down root 13. And that's that point over there. And I'm going to say, for the most part, draw the picture of this thing. And I'm never good at drawing pictures, by the way. But the ellipse, and I'm tracing over my own picture, by the way. What I mean by that, the computer picture. All right. And I got points over here. Those points have been clearly indicated to you. All right, let's go to the next question, which is, I gotta look at my notes again, make sure I'm doing what I said I was going to be doing. We just did problem number 1. We're going to go do problem number 2 now. And number 2 says, find the standard form of the equation of the ellipse with the given characteristics. What I would recommend for a majority of students to do is to get a rough picture of what they've given you, and then we'll determine what the equation is. The vertices are at 0, plus or minus 8. Whoops, made a mistake already. That's along the y, right? This is going to be 0, minus 8. This is going to be 0, plus 8. All right. The foci are at plus or minus 0, plus or minus 7. So foci 0, 7, 0, minus 7. And I'm not saying I'm going to do a great job, but there's my ellipse right now. All right. Now I'm looking at it, and I'm pretty clear that the center should be sort of obvious to most students, just 0, 0. So I'm kind of ready to write that down. I'm going to write that down for you. So, whoops, x, still that red ink, x minus 0 squared over something. I haven't gotten that far yet. And y minus 0 over something. And again, I haven't gotten that far yet. And this is going to be a 1 over here. Now, what I do know is I know a point on the ellipse. And the point I know this point's on the ellipse. I know this point's on the ellipse. I'm just going to plug it in. And what does it say? It says x is 0. Well, if x is 0, this first term would disappear. But then y is either plus or minus 8. And what would I get over here? I would get 64. So if this disappeared and this is 64, the number on the bottom must be 64. Let me write that down for you. All right. Now the major axis I'm looking at along the y's. So what am I looking for? I'm looking for this thing now. And what do I know? I know 64 minus that thing squared is going to be equal to the c squared. Question is, what's the c? The c is the distance in from the center to the focus. And what is that? It's 7 units. So what's c squared? C squared is going to be 49. So it's going to be 64 minus 49 is equal to that question mark squared. And 64, it's 15, right? Now mistakes happen. But anyway, let's go back over here. I'm going to get my eraser at now. I know this question squared is 15. At least I believe it is, right? Let's try to neaten this up a little bit. So it's going to be x squared over 15 plus y squared over 64 is equal to 1. All right? I'm seeing that right here. Again, make sure you're looking at the key as we present things to you. All right, let's go to number, let's see, I guess I'll do number 3 now. We just finished 2. And again, my understanding is they want, find a standard form of the equation of ellipse with the given characteristics centered at the origin. So let me write that down for you. Notice center. It's the origin, which means 0, 0. Right, and it's an ellipse. And it says with the given characteristics. And again, what I'm going to do, I'm try to draw a picture of what I think I'm seeing. I'm seeing a center here. And I'm seeing the foci at plus or minus 6. And the major axis length 14. The major axis goes through those foci. And if it's 14 units long, it means the vertex here is at 7. And this vertex is minus 7. So put this over here. Again, I'm not saying I'm doing a great job, but it doesn't have to be a great job. It has to be enough for me to visualize what I'm talking about over here. So I'm going to start to write it down. What's going to be x minus 0 squared over something plus y minus 0 squared over something equals 1. Now, the one thing I do know is I do know the point on the ellipse has to satisfy this. And what do I know about this point over here? This point over here is 7, 0, and this point over here is minus 7, 0. Well, if you plug that in, again, I want to emphasize what happens is this second term just disappears because if y is 0, I get nothing here. And what happens over here? This would be plus or minus 7 squared, which is 49. And 49 divided by what would give you 1? Well, it has to be 49. I don't know that yet. Let's talk about it. It's the difference between those two. And again, the major axis along the x-axis equals, well, let's look at it. And the question is, what's the c in the problem now? Again, I want to emphasize what the c is. It's the distance in from the center. And what's that distance? 6. So what's 6 squared? 36. Let's write this down. 49 minus 36 is that question squared. What's 39 minus 46? Let's see, that would be 13, right? Let me get my eraser out, erase this. I'm gonna put 13 down now. Let's neaten it up. You're gonna get x squared over 49, we'll check the key later, plus y squared over 13 is equal to 1. All right, I make mistakes. That's why I want you to encourage you to look at the answer key to make sure nothing has gone awry. All right, let's take a look at number 4. And again, as I go through these problems over here, you should really think about what we're making you, not making, but asking you to do is think before you act. It's like a memorization problem. It's, I'm going to think before I act. Again, it's an equation of ellipse, and I'm going to draw my picture of what they've given me. And the foci are at 0, 0. That's easy. The other foci is at 8, 0. And then when I do that, this is, 0 and this is 8. So the center of that would have to be 4. So I know the center. I'm going to write that down for you. I know the center by just doing that is going to be 4, 0, right? I also know the C by looking at that. And what's the C going to be? It's going to be 4. All right. So let's keep looking at it. And as I look at these things, I want to talk about what the major axis means. It means the distance in from the center, right, has to be 9 units because the major axis is 18 units long. So I got to go 9 units in that direction. Where would you land? Where if you had 4 and you go 9 units in, you'd be at 13. And if you're at 4 and you go 9 units to the left, what number would you be at? Let's see, 4 minus 9 minus 5. Again, I'm not saying it's terribly important to draw the ellipse in, but I'll do my best job. That's minus 5, by the way. All right, what am I going to do? I'm going to write the equation down now. So it's going to be x minus 4 squared over something plus y minus 0 squared over something is equal to 1. Let's talk about it. I know points, and I'll tell you what the points I know. I know the point minus 5, 0, and the point 13, 0 is on the ellipse. That means it's got to satisfy that equation. What's nice about that is something disappears if I plug that point in. Either one, this disappears. So I'm only worried about this. So 13 minus 4 is 9, and 9 squared is 81. Let me try the other one. Let's say I put minus 5 here. What would you get? Minus 5 minus 4, which is minus 9 squared, still 81. That certainly satisfies it. Now here comes the tough part for a lot of students, getting this guy over here. Again, the major axis along the x. So what do you get? 81 minus, this thing squared is equal to c squared. What's c? 4. What's c squared? 16. 81 minus 16 equals the question mark squared. What do you get there? 65, right? Yeah, 65. Let me get my eraser out. I'll put 65 down. I'll clean it up now. If you clean this up, what do you get? X minus 4 squared over 81 plus y squared over 65 equals 1. All right, I'm seeing it. All right, so, we're working through the problems, of course. We want to get to the next one. And next one's going to be the next page, which is problem number 5. Let's take a look at number 5. And the picture's there for me for good reasons, all right? But anyway, let's take a look and see if we can read it. Number 5 says, find the standard form of the equation of the ellipse. Oh, that's not an ellipse. I got the wrong thing there. We'll talk about that later then. That's not the picture of an ellipse, by the way. That's a picture of a hyperbola. So let's put number 5 down. I'm going to blow this up. And this is definitely an ellipse equation. So it's going to be the center. So I give you, they give me the center. I got to be honest, that seems like it might be pretty easy to write down. So it's x minus 7 squared over something plus y minus 4 squared over something is equal to 1. I'm still going to draw my picture. And so why do you draw a picture? I'm going to see if I can understand what this thing's going to look like. And it says that foci are at 1, 4. Let me say maybe you're about over here somewhere. And then 13, 4 over here. All right. And I'm looking at those things and I'm wondering, what would the center of that be? Right. And I'm going to look at that and I'll make sure that what they're giving me is correct. Well, the center would just be the add them together and divide by 2, right? So 13 plus 1 is 14, and 14 divided by 2 is 7, and 4 plus 4 is 8, divided by 2 is 4. Well, exactly what I expected it is. No news there. All right. All right. Here comes the problem now. I'm looking at it, and I want to point out this is the case. My ellipse is going to look like this over here. And I'm exaggerating, by the way. And this is where the major axis is. All right, and the center's over there. The question is, what am I going to do now? I'm going to think about the C in the problem. And the reason for that is I can see the C. Right now, why can I do that? I see these points, 1, 4. I see the center. The center is 7, 4. And I see the other focus was at 13, 4. Now, what's the C over here? Well, what's the difference between that? Is 1 to 7 is 6, right? And 7 to 13 is also 6. So C is 6. Now that's important to me. And I'll tell you why it's important. It tells me what A is. So what's A going to be? Let's write this over here. A is 3 times that C, which is 18. Now, again, the major axis is along the x direction. So this is going to be below the x's. So the A is going to be 18 squared now. All right. I got this question mark squared over here. I don't know what it is. All right. So before I do anything, I'm going to tell you that 18 squared minus this question mark squared has got to be C squared. What do we determine C is? 36. All right. C was 6, so C squared was 36. All right. I got some work to do. And I want to point out the way you do it, the way I do it, it doesn't matter. The truth cannot change in the end. And I'll be more than happy to fess up to any mistakes I make. Let me put 18 squared down for you, though. And what's 18 times 18? I'm going to do something a little crazy for you. But 180, that's 10 times 18. 8 times 10 is 80, and 8 times 8 is 64. I'm going to give you 4, 16, 22, and 324. So I'm going to erase that here and here, and I'm going to write down 324 now. Okay, now what am I going to do? 324 minus 36 is equal to the question mark squared. Well, I'm going to put it on the side for you, and that's 326 minus, I'm sorry, I got 6 in my brain. It's 324. We have a key to look at, don't worry about that. Well, let's see what you get over there. Let me borrow. And let's see how to borrow here. 8, 288. The question mark is 288. Squared, I mean. Let me write that down for you. Get my eraser out. And this is 288 here. Let me just clean it up a little tiny bit, put in one color, and make sure we get what we need. X minus 7 squared over 324 plus y minus 4 squared over 288 is equal to 1. You're going to make mistakes, by the way, and that's why we give you the K. Do we have the same answer they have? Sure enough, we do. That's good news. All right, let me go to the next one. And the next one is this business over here. All right. Someone says, I wonder what question that is. Well, that's question number 6. I'll put this down now. Now, someone says, why don't you put down the actual question? I'm reading it. It says, find the center of this. So this is hyperbola. And I'm looking at this thing, and it's really simple to get the center from. I'm looking at the form, and it's in the exact form I want. And that form, let me write this down over here. It's y minus 0 squared over 4 minus x minus 0 squared over 16 is equal to 1. So the center is really easy to determine looking at that. And let me write that down for you. The center is just 0, 0. All right. If you look at the key, you'll see that. Now, next question up is what is the vertices of it? And I'm looking at it, and I'm going to, certainly tell you what we've done, at least we discussed in class. We would like this term here to just simply, I would say disappear. And what number would make this thing disappear? 0. I'll put that down for you. So the x is 0. All right. Now, what are we left off with? We're left off with something that's rather simple to do. We're left off with this term over here. And in this term over here, if this is 0, it has to equal 1. So this thing has to be 4. And what value of y would make it 4? Plus or minus 2. These are the vertices. Let's look at the picture and see how we're doing. Center, vertices, 0, 2, 0, minus 2. All right. So I say I'm comfortable with that. All right, let's go to the next one, the foci. All right, I see the foci in the picture, and it's nice to know the foci are there in the picture for me, and certainly they're accurately drawn. And how do I do that? Well, I'm going to write it down for you. So c squared is going to be the sum of 14 and 16, which is 20. So c would be the root of 20. Or if you prefer, which some people do, to simplify that, and that would be 4 times 5, so 2 root 5. What do we have to do? Go in from, right? We have to go in from the center. Of course, when I go in from the center, 2 root 5s, where would I get? 0, 2 root 5. All right. What's this one over here? 0 minus 2 root 5. All right. Let's keep going. Next thing they ask about is what are the asymptotes? And again, this is where some students get really confused. What I want to point out to us are extreme behaviors. It's when x and y are going off to either plus infinity or minus infinity. My claim is this: when things go off to plus or minus infinity and they differ by 1, they really become equal. So I'll write this down for you. So y squared over 4 is essentially the same, at least asymptotically, with x squared over 16. So I'm going to write this down. Y squared equals 4/16 x squared, square root rule, y equals plus or minus the square root of 4/16. Well, that's a quarter, right? So it's going to be 1/2 x. All right. Look at your key. Make sure you're staring at that. All right. So let's go to the next page. That was problem number, make sure I did that right, 6, right? So we'll go to 7 now. And I'm looking at 7, look at the picture of it. I'm going to put this over here. And again, I'm going to blow that up for you. All right. Hyperbola. And I'm looking at it. I'm glad they provide a picture for me because it allows me to just talk about the picture and not necessarily graph it. You do need to get the skill set of being able to construct a picture. And yes, I have constructed a picture, although electronically, I was still able to construct that picture with all the characteristics I want in that picture, which are the asymptotes, center, vertices, and the foci. Let's talk about it one step at a time. Let's talk about the center. Well, it's written in standard form, So the center is going to be really easy to write down. The center is going to be, let's see, -3, comma 1. That's done. The vertices. Well, the vertices, what I want to point out to you is I want this thing to disappear, and this thing would disappear when y equals 1. So I know y is 1. Give me 2 vertices, by the way. Question is, what's the x? Well, that should be easy to do, provided we give you nice numbers. So if this disappears when y is 1, I'm left off with this. And what would make this, 1? It would have to be 25 here, right? And what number would do that? Well, 2 would, that's certain. We'll check this in a picture later. And what's the other number that would produce that? Well, 2 plus 3 is 5. And also, if I want to make this -5, I'm going to say -8. All right, let me look at my picture, see how we're doing. Is the center -3, 1? Yes. Are the vertices 2, 1 and -8, 1? Yes. I'm doing all right. All right, what else do I want to do? Okay, if you don't know, I'd say read the notes. They want to get the foci. And so I'm going to write that down for you. C squared is the sum of 25 and 16. C squared is going to be 41. C is root 41. So what I need to do is I need to move in from the center. These are going to be the foci. Now, if I move in from the center, question is what's not changing? The y is not changing. So the y is always going to be 1. Now, if I'm moving in from the center is -3, right? So I'm going to say if you move to the right, you have to move to the right root 41. So I'm going to say root 41 minus 3. I move to the right root 41. The other possibility is moving to the left. That's minus root 41 minus 3. Now, granted, that is a nasty number. I do want to point out you can approximate those things, and you'd find these points over here approximately correct. All right, so certainly, again, I want to recommend you look at the answer key, and these answers are in the answer key, by the way. What else? They asked for the asymptotes. So again, I want to communicate to you that asymptotes, what we're looking at is when things get extremely large, x and y, they do differ, but they differ by 1. But if you're getting really big, differing by 1 has no impact on it. So what am I saying over here? They're basically equal. And let me write that down for you. So y, whoops, let me go back to black ink. Y minus 1 squared over 16 is going to be equal to x plus 3 squared over 25. Well, y minus 1 squared 16 over 25 x plus 3 squared. Square root rule, y minus 1 plus or minus, well, the square root of 16 over 25 is 4/5 x plus 3. Tradition as we saw for y, and y is going to be equal to 1 plus or minus 4/5 x plus 3. These are the equations of the asymptotes. I'm going to go over here and write them down next to the problem. This equation over here is going to be y equals 1 plus, why do I say plus a positive slope? 4/5 x plus 3. And this line over here that's got negative slope is going to be y equals 1 minus 4/5 x plus 3. All right, nice to have a graph to look at. I also want to point out in the answer key that we give you the asymptotes as well. All right, so I think I'm going to move on to problem number, and again, that was problem number 7. I'm going to move on to problem number 8 now. And let me just move on to problem number 8, right over here. So number 8, really same story. What am I seeing? I'm seeing hyperbola. I'm seeing its equation. And my first goal is to get the thing into standard form, because otherwise I'm not going to read the points off from it. And to get in standard form, it requires some work, but it's not going to be so much work you can't get through it. So let's put this down. So I'm going to write it down for you. 16x squared minus 25y squared plus 50y equals 425. That wasn't so bad. 16x squared minus 25 y squared minus 2y equals 425. Again, my hope is numbers are going to work out really nicely. 16x squared minus 25 y squared minus 2y. If you're completing a square, you're taking half of the minus 2, which is minus 1. You square it, you get plus 1. I am not adding 1 to both sides. I'm actually subtracting 25 from both sides to make that equal. What do you get over here? 16x squared minus 25, and this can be y minus 1 squared equals 400. Now what I'm going to do, divide both sides by 400. And yes, we do write them so the numbers work out pretty nicely. What do you get? X squared over 25 minus y minus 1 squared over 16 equals 1. All right, so I'm going to say that that's not bad. So someone says, what do you mean that's not bad? I can actually read a lot of information from that. So for one thing, I can read the center to you. Just from that, just from this over here. The center. By the way, before you move on, you may want to look at the key, and the key says that we got that standard form correct. So the center is going to be read off from this. What is going to be? X is going to be 0, and y is going to be 1. Let me see if I got that right, my picture. Wow, right here. All right. I'm also going to get the vertices. All right, looking at it, I want to point out what I'm looking at. I'm looking at this over here. I want this to disappear. That could only happen if y is 1. So I write that down. It can only happen if y is 1. It can only happen if y is 1. Then the big question comes is, what would the x have to be if this disappeared? It would have to be plus or minus 5. I'll put that down for you. Let's see if we got those points right. Which is going to be minus 5, 1. I see that there, and 5, 1. I see that there. All right, let's talk about the foci now. How do I do the foci? Well, it's c squared is going to be 25 plus 16. C squared is going to be 41. All right, and that means C is root 41. What does it mean? I got to move in root 41 to get the foci. And what am I moving in from? The center. And so if you move in from the center, what's not changing is the y is not changing. So you're going to get root 41. I'm moving everything up, which is 0, 1, and it's going to be minus root 41, comma 1. All right, let me tell you where those points are. I know it's difficult. They're right over here. All right. So if you're looking at the key, again, when I say look at the key, you're seeing the center, you're seeing the vertices. If you're looking at the key, we want to encourage it, and you're looking at the foci now. All right, you're looking at that. It's all written down for you. I want to do the asymptote now, right? What am I saying? That these two terms are relatively equal. Whoops. So y minus 1 squared over 16 would be the same thing as x squared over 25 when x and y gets really large. So we'll write this down. So y minus 1 squared is 16 over 25x squared. Y minus 1 equals plus or minus 4/5 x. Well, I typically solve for y because that's what you did in Math 100. And not that you have to do that, but y equals 1 plus or minus 4/5 of an x. Again, if you're looking at the key, you also see that. I want to go back to the picture and point out where those lines are. This is the line y equals 1 plus 4/5 of an x. And this is the line over here, y equals 1 minus 4/5 of an x. And yeah, certainly drawing the parabola, drawing in the hyperbola now isn't such a big deal. But I'll be honest with you, I have a tough time doing it by hand. On a machine I don't have trouble with. But sort of, since like the picture there, and I'm still doing a bad job tracing over it, right? Something like this over here, asymptotic, and it's going through the point that we said it would go through. So let's take a look. And what I want to do is I want to go to problem number 9 now. All right. So we just finished that, number 9, and number 9, and then we have number 9 and number 10. Let's look at number 9. And again, this says, find the standard form of the equation of the hyperbola with the given characteristics. Well, again, what I'm going to claim to you is that it's really important to visualize. Now, someone says, do I really need to draw this on a piece of paper if I see this in my head? No, you don't need to do that. But let me put this down. I got the foci at plus or minus 8, 0. So put this over here. It's 8. This is the foci, minus 8. These are the foci. And I got vertices at plus or minus 4. That's not so bad. And I'll put this minus 4 and 4. And I got a pretty good idea that this thing looks roughly like this over here. You know, asymptotes, may not know what they are, but sort of like this over here. So the other question is, you know, what are you going to write down? Well, they want the standard form. So I'm going to put the center down for you. And what's the center? Well, the center here, looking at it, is just 0, 0. And I'm just looking at the picture. It's hard to get that wrong. So I know that I'm getting something. I'm getting x minus 0 squared minus y minus 0 squared equals 1. I don't know the bottom numbers yet, though. So what I'm going to claim is that I think I can get some of them. And by that, what I mean is I know the vertices, and the vertices are going to be right over here. So what do I know? I know the y is 0. That means this term disappears, but the x is plus or minus 4, which means this would be 16. So what goes on bottom? It would have to be 16. All right. What's the next thing I know? I know c. What's c? C is 8. What is c squared? 64. So I'll put my little question over here, squared. 16 plus that number must be 64. So what's that thing equal to? Well, 64 minus 16 is 48. Let me get my eraser out. We'll look at the key later, but I want to clean it up a little bit. This is going to look like x squared over 16. Whoops, I didn't mean to say that. Minus y squared over 48 is equal to 1. We're seeing it right there, which is good news. All right, let's do the next one, which number 10, a little more complicated, but I still want to draw a picture of it. And I would say it doesn't have to be a great picture, but enough to say that you know what you're looking at. And I'll put this one over here. Vertices plus or minus 9. It's along the y. It's got to open up like this over here. And they got the asymptotes. And the asymptotes, wow, that's easy. And this is just a rough picture. I'm not saying it's good. It doesn't have to be good. I know the center. Just looking at that picture over here. Center is 0, 0. I know the form of this one too. What's going to be y minus 0 squared over something, right? I don't know yet. I should maybe put a question mark there. Maybe I'll jump in the gun on that one. Minus x minus 0 squared equals 1. All right. Now, what else do I know? I know the vertices. All right. I know the vertices over here. I'm just going to plug them in. I think by plugging in, I'll be able to figure this thing out. I know x is 0, so that means the second term disappears, and y is plus or minus 9. And plus or minus 9 minus 0 is plus or minus 9, and that squared is 81. So this must be 81. This is the thing I don't know. And let's go through that. And someone can say, how do I do that? It has something to do with this business over here. What am I saying? It's asymptotic behavior. So let's write this down. What do you get? You would get y squared over 81 is x squared over this crazy thing here. I don't even know what it is yet. Let's see if we can figure that out. All right. I don't know if I can. So what do you get over here? Y squared is equal to 81 over something squared, x squared. What's y equal to? Plus or minus 9 over this question, x. Only thing I know is that 9 over this question is equal to what? 3/4. Let's see if we can figure that out. And what are you going to get over there? Well, let's see if I multiply both sides by 4/3 and then question, oh, that's not so bad, is it? That would give you 12. So what's this thing squared? 144. Let me get my eraser out. We'll check it later. I'm going to clean it up first. And what would I get over there? Well, I get y squared over 81 minus x squared over 144 is equal to 1. We're in agreement. all right, which is not bad to be in agreement with the K. Okay, I think we just did 10, and that covers it. I know it's a tough section. You have to study, and you have to do supplemental problems on your own. Thank you.